Hello, everybody. Hi, my name is Spencer Whitehead, and I want to first off say congratulations to all the award recipients. I mean, great job. You know, navigating college successfully, especially as successfully as all of you, is a very tough task, and you should be very proud of your accomplishments. And I wish you all the best going forward. So today I'm going to be talking about understanding vision and language. So in large part, that's really what my research goes towards, is allowing computers to understand and comprehend what they see visually as well as what they read in text. So first, a little bit about me, just to kind of give more of an introduction than the bio. But so my interests are natural language processing, computer vision, and machine learning. And these really go hand in hand with one another. And I think you'll kind of see that as we go through the slides. But some of my hobbies are hockey, lacrosse, and traveling. So that's me and that right there. Yeah, I probably was about to get scored on, but
Can't see the puck.
Yeah, exactly. We don't know where
it looks like you blocked it.
There we go, yeah.
I think the Penguins have an opening in goal.
I was thinking about trying out. We'll see how it goes. But yeah, so mainly what I like to deal with is unstructured multimodal data, right? So you can think of image caption pairs or news documents that have images or videos embedded in them along with text. And basically what we want to do is extract the who, what, when, where, and why from this information, right? So we want to take this unstructured data that we have and turn it into a structured format such that we humans can use this, right? So you can imagine nowadays, let's say you're a military analyst and you want to understand a situation that's happening in a foreign nation. In order to do that, it's going to require a whole bunch of people reading news documents, government reports, all these different things that could be in multiple different languages, and there may be thousands and thousands of them. So it's not really always feasible for humans to go through this. So this is where my work comes in, which is you can automatically give my system thousands and thousands of documents that have images and text in them, and we can extract out all the relevant knowledge from this and display it to an analyst. So at the end of the day, basically what we want is this. So we want to pull out all the entities, the events, the relations, and we want to be able to display them from the text standpoint as well as visually. So this is kind of what we're going towards, and I'll kind of lay out the process of how we do this. So from top to bottom is our flow from input to output. So input is our text documents, images and videos. And what we do is we have a couple different pipelines that operate on the text side and on the vision side. And then we sort of fuse them together at the end in the best way that we possibly can. And then give you this multimodal knowledge base as output that you can use. So from the vision side, one of the things that we do is object recognition and object detection. So basically, if we're given some images, we want to automatically extract out the different sections of the region that correspond to certain objects. So here you can see different things like helicopter, person, car, different things like that. So our object detection system that we use can detect, I think, over 1,000 different objects and put bounding. These are called bounding boxes, is what you're seeing. So the second step is we also want to recognize people, which recognizing people is an exceedingly difficult problem. So you can imagine a computer has to learn from the data that it's seen before, right? So if you get a new person, it's incredibly difficult to say, oh, you know, and I guess assign a name to this person. So so in this example we've recognized Kirsten Nielsen, a Marine. But then we also can recognize just different faces and keep different facial clusters, right? So then if we see a similar looking face in the future, we can put that in its corresponding cluster, and then eventually if we can name it, we will go ahead and do that. So it kind of adapts as you get more and more data coming in. So at this point we've had the entities from the vision side extracted, so now we kind of switch over to the text side. So from the text side, we do entity discovery and linking. So basically, we have a system that reads through all the text, and we'll pull out the different named entities. So that's people, places, geopolitical entities, names of buildings, things like that. we'll pull all of those out of the text and we will link them to our knowledge base. So you can think if we wanted to start off with a simple example, maybe Wikipedia, right? So we want to say that when we see this person's name of Prince William, we want to be able to say, oh, here's the Wikipedia page for Prince William. So we know exactly what entity that mention in the text corresponds to. The next thing that we do is event and relation extraction. So relation is, you can think of like a person to an organization. So Spencer is employed by Rensselaer Polytechnic Institute. Or Spencer is located in Westbury, I believe we're in. Sorry, I'm from Detroit originally, so Long Island is not my stomping grounds. But yeah, so we extract all the relations, and then events are just, I guess, just exactly that. So events, so maybe protests, attacks, business transactions. So let's say the sale of a company or the signing of some agreement between two entities. And when we extract out the different events, we also want to know what role do they play in each. So in this example, we have that Prince William was having a meeting in Israel, and he was one of the participants, and we also have that Israel was the place, right? So we want to know specifically what role each entity plays in the event. So I have a little demo here of our system. So our entity discovery and linking system can handle 282 different languages, and it's a very widely used system. And actually, this demo, along with the public API, is available on our website if anyone wanted to try it out. But basically, this is just a visualization of what we've extracted, right? So we can go here on the map and see the different examples of what we extracted in text. So here, Oromo is a very, very not widely spoken language. I think worldwide it has roughly like 100,000 to 1 million speakers, something in that ballpark, like very, very low. So part of this project that we built this demo for was actually to handle low resource languages, right? So if you have to go and understand documents that are coming from another nation whose language you have no idea how to handle, how can you still extract this knowledge or this information and link it up with what you already know? So at this point, we've now extracted basically all the information that we can independent for the two modalities, right, vision and language. And at this step is where we want to kind of link across them. So at this point, what we do is we take the different entities that we detected in text and use them as queries and try and find the best match in the image to that query entity. So actually the system that we have, so this problem is called grounding. And in collaboration with Columbia University and some of their researchers there, we have a state-of-the-art grounding system currently. So these are all real examples from the system. So you just give it that sentence and it will tell you where in the image it the different pieces of the text refer to. So in the first one you can see a cute young boy, and that basically it puts a heat map over the different sections of the image and says here is where a cute young boy is, or an American flag, or onlookers, whatever it might be. So this is kind of where this fusion comes into play, where we want to actually match what we see visually with what we're reading in the text. So at this point, we kind of have our output, right? So we have all the events. We know what entities we're looking for. We know how the entities are related to one another. And we also know what they look like and also where we can find them in the text. So basically what you end up with is this multimodal knowledge base that you can run complex queries on. So you could say something like, show me all transaction events that occurred between this company and any organization of this type. So let's say it's like a humanitarian organization or something like that. You can run very, very complex structured queries on knowledge or information that came from unstructured data. So I guess, yeah, that kind of embodies some of the largest benefits that you get from this field of research, right? So you can ingest, again, thousands and thousands and thousands of documents in seconds and have this produced that you can write queries for and basically do whatever analysis you might want to do. So in all, it kind of expands and it expedites and widens the scope of your analysis capabilities, right? So in terms of analysis, you can do complex event understanding. You can determine causal factors or sentiment. So a causal factor, right? Why did this attack happen? You can kind of trace the chain of events back using our output. You can also do prediction and forecasting. So one of the things that our group has done was human moral value prediction, right? So based off of tweets and other social media data from a certain region, you can estimate what those people value morally the most, and you can sort of predict, okay, if they value obedience more, maybe they are less likely to protest. And you can kind of hedge your bets from there based on these estimations of what the people in the region believe. And then you can also do things like summarization, right? So actually one of the projects that I worked on, so this is the idea that I came up with, where basically I want to do video captioning. So you give my system a video and it describes to you in words what's happening in the video. But no one had ever done this for news videos because recognizing people is such a difficult problem, and as well as locations. So there's a great deal that you can do with this multimodal knowledge, and it can help in a lot of different ways. So so I guess in general, these are kind of the themes of what you can do with information extraction, and specifically this combination of multimodal information extraction. In particular in finance, information extraction is actually incredibly useful. So I attended a talk from Gideon Mann. He is the lead data scientist at Bloomberg. He came to the conference that I was presenting my work at. This is actually one of the plots that he showed. I found this very interesting. So this is a plot of the stock values, and on the bottom is time. So the news that Broadcom was going to explore a deal to acquire Qualcomm, the yellow line that you see over here on the left is when that news first hit the public media, and then as time progresses, you can see the value of the stocks or the prices that they're trading at increase, right? But the difference between those two times is actually less than roughly a tenth of a second, maybe 0.15 seconds, right? So if you have an automated system figuring out what events are happening, right? So a transaction is one of the things that we look for in text and we can actually handle. If you have that faster than anyone else, you can come out pretty nice on this, right? And make yourself a little bit more money, I would say. So basically this expedition of your analysis process, or how you're taking this information in, can be of great help. And especially the multilingual aspect of it too, right? So if some deal is happening, let's say in China, between a Chinese company who you own stock in their company, if that's possible. But you can still perform the same analysis even if all the documents are in Mandarin or Cantonese, whatever dialect it would be. So my background is not in finance, but I guess just from someone working in this field, a couple takeaways that I thought about was, first of all, when you're looking into AI, if you're thinking about applying that or it's part of your business operations, I think there are a few key things. So the first thing is know your problem, data, and technical resources. So does your problem require AI, right? Is it a predictive problem? In terms of knowing your data, what I specifically mean like that is not all data is usable. So Sanjay mentioned this expansion of dark data. Sometimes the data set that you have publicly available or that you could collect may not actually be useful for solving the end task that you want. So you have to carefully understand that. And then also know your technical resources, right? Because this is science, and science is not always perfect. So there may be limitations that come into play in your problem that may not have existed in a different problem that may have been more controlled. And then yeah, in terms of what to expect, so the sooner is really collaboration between artificial intelligence systems and humans, right? So using AI as a tool. So clearly the work that I just presented is largely going towards having this as a tool for human beings, right? So we're most interested in reporting this to analysts, right? So we want to put the information in your hands as fast as possible, as well as succinctly as possible, and allow you to perform your job in the best way that you possibly can. In the longer term, you are seeing more trends towards general intelligence. So there are certain companies like OpenAI that really work on general intelligence and reasoning through environments and things like that, as well as continuously learning in open domains. So what I typically work on is not usually open domain, so you kind of have to define the target of what information you're looking to extract or what knowledge you're looking to extract. But there are people that are working on doing this just in general and automatically learning what that target of information is. And actually, my group and I will be kind of starting on that actually probably in the next year or so. So yeah. I also have a couple other things that I just wanted to show that kind of demonstrate some of these things between, I guess, vision and language. So this was a project from IBM's research group. So this is interactive, dialogue-based interactive image retrieval. So this kind of goes towards chatbots, right? So basically you can just type in whatever you're looking for, and then it will show you an image that it thinks that you're talking about. And this is all automatic. So right now this is someone talking to a chatbot, and it's basically iteratively refining your search. So it's almost like a personal shopper, or an automated personal shopper. So that was one thing, and then these last couple things I think are just rather interesting. So this is a problem called video retargeting. So to be honest, when I first saw this, I thought this is the end. The apocalypse is coming. Yeah, so basically the input to this system is the video on the left, and then the output is the video on the right. So you basically take a video of someone and you make it look like it's somebody else. So yeah, so there's some pretty interesting work going on. So this is one of the things that researchers in computer vision are kind of working towards. So one of the practical applications of this is if you're in media and you want to, say, shoot a scene, right? Or have even just like a demo of what you think the scene might want to look like, or maybe if you don't want to put someone in full makeup, you could do something like this and kind of automatically make them look however you want in real time. And then the last thing is, so this is celebrity image generation. So this was from NVIDIA, and what this is doing is basically, so all of these people that you're seeing are not real. This is the computer just making these images up. So basically their system learns to map random numbers to real images. So there's a lot of different work going on in this direction, and actually one of the things that I'm also interested in doing is generating images automatically given natural language descriptions. So yeah, I guess basically in computer vision and natural language processing, there are a lot of really cool and exciting research directions that we can go into. And yeah, sometimes it devolves into nothingness, but at certain points it looks pretty good, I would say. So yeah, overall I would just say AI is, I would say, a really blossoming field with a lot of advancements going on in it right now. That's very, very exciting. Utilizing it in an intelligent way in your company, I think, is a prospect that can offer great benefits when used correctly. And the field of, my fields in particular, natural language processing, computer vision, I think are really two of the most exciting areas within AI. And I personally think they deserve more and more attention. So thank you very much for having me.
You know, when we had a little pre-call here, one of the things I found interesting, we started talking about when a public company has their earnings call, and how the information can be dynamically captured to predict the reactions that the public will have to what's said by the CEO and the CFO during that call, and just think about the applications of something like this, which is just, you know, I've spoken to Spencer about the research he's doing, and I just think, wow, how could this be applied, and knowing the people, a lot of the people around this room in the businesses that we work in. And it's someone said, oh, it's time to retire, right? But the reality is this is where it's going. And you know, to the academic world, I think it's interesting that the question was great. How does academia react to this? Well, they need to be aware of it. They need to make sure that they're creating the majors and educating the students to that. You know, I spent some time at Stony Brook in the recent past, and you know, I always would talk to the people and say, well, they said, well, we're launching this new career, and I said, well, how are you evolving? What are you sunsetting? Right? Because this is replacing things, and you know, for accountants out there, the days of doing account reconciliations manually, well, a lot of us in the room have done that, but the new people that are coming up into the workforce, they're going to rely on the computers to do, through these applications, right, to do those reconciliations, and now you're interacting, you're reacting, and you're doing more analytics of that. And so the jobs are changing, and I think that was, the point was made very well by you when you had those percentages up there, you know, and some of them were quite high, you know, yes. 50%, 60% of certain fields are going to be taken over, and by the way, going to be is, they are being taken over, right? Yes. This is here. So I think it's just fascinating. I think you guys did a great job at